Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Okay, today we will discuss on topic man group elements in chapter 8 of ASC0304. Okay, man group elements consist of group 1, group 2, group 14, 17, and 18 in the periodic table. Okay, this is the learning outcomes. At the end of this chapter, you should be able to describe the trends in physical properties, which is atomic radius, first ionization energy, electronegativity of group 1, and group 2 elements. Okay, describe the reactions of group 1 and 2 elements with oxygen and water. Okay, describe the trend in physical properties of group 14. In this group, we will discuss melting point and electrical conductivity. Okay, explain the bonding and molecular shapes of the tetrachloride of group 14 element. Okay, explain the relative reactivity of group 17 element as oxidizing agent, and explain the innerness of the noble gases. Okay, first we will discuss group 1 elements. Also known as alkaline metal with one valence electrons. Okay, the elements are soft, very reactive, and shiny, silvery surface. Okay, this is the locations of group 1 elements in periodic table. Okay, alkaline metal consists of lithium, sodium, potassium, rubidium, cesium, and francium. But francium is radioactive, and we will not discuss in this lesson. Okay, this table shows the physical properties of group 1. Okay, generally the proton number, atomic radius, the first ionization energy, and electronegativity increases when going down group 1 from lithium to cesium. So the electronic configuration shows that the valence shell electronic configuration is NS1 in general, with one valence electron. Okay, the first physical properties we will discuss is atomic radius. Okay, the atomic radius increases when going down a group from lithium to cesium due to the increases of a principal quantum number. Therefore, the shading effect also increases. Okay, due to the greater number of inner electrons shielding the valence electron from the nucleus. Okay, so the attraction between the nucleus and valence electrons become weaker than, and the valence electron further from the nucleus. So the atomic radius will increases when going down a group. Okay, for the first ionization energy, okay, when going down a group, the first ionization energy will decreases because of the increases of atomic radius. Okay, when the atomic radius become bigger, means easy to remove valence electron from the atom. Okay, therefore, the first ionization energy for the when going down group 1 will decreases. Okay, for electronegativity, okay, electronegativity also decreases when going down group 1 due to the increases of atomic radius. When the atomic radius become bigger, the valence electron are further from the nucleus. So the bonding electrons is less attracted to the nucleus. So the ability to attract electron toward itself, become weaker. Therefore, the electronegativity decreases when going down a group. So for chemical properties, for alkaline metal, easily oxidized and very good reducing agents. All alkaline metals form the metal ion by losing one valence electron. The easier metal ion form means the easier chemical reaction occurs. Descending group 1, the atomic size increases and the ionization energy decreases. Therefore, the element easier to form metal ion and become more reactive. Group 1 elements react with oxygen very reactive, to produce metal oxides, and metal oxide form basic solutions when dissolved in water. So alkaline metal combined with three different ionic oxide, which is a common ion, peroxide ion, and superoxide ion. The more complicated ions, such as superoxide ion, are unstable in the presence of a small positive ion. Going down a group, the ionic size increases, meaning the element at the bottom in group 1, such as potassium, rubidium, and cesium, tend to react with a superoxide ion. Lithium react with common ion, burn with red flame. Sodium with peroxide ion, burn with orange flame. Potassium, react with superoxide ion, burn with visible flame. While rubidium and cesium, react with superoxide ion, ignite in air. Group 1 element react explosively with cold water to produce metal hydroxide and hydrogen gas. All group 1 elements react with water will produce metal hydroxide and hydrogen. Now we move to group 2 elements. Group 2 element also known as alkaline earth metals, with two valence electron. The element are soft, reactive, shiny, savory white metal surface. Group 2 elements are less reactive than group 1 element or alkaline metals. This is the locations of alkaline metals in periodic table. Consists of beryllium, magnesium, calcium, strontium, barium, and radium. But radium is radioactive, and we will not discuss this element in this lesson. Physical properties for group 2 elements. The valence shell electronic configuration is ns2, with two valence electrons. The proton number, atomic radius, the first ionization energy, and electronegativity increase when going down group 2. The reason of the increases of atomic radius when going down group 2, same as group 1. The first ionization energy also decreases when going down group 2. Okay, the reason also same as group 1. Okay, the electronegativity also decreases when going down group 2. And the reason also same as group 1. Okay, for chemical properties, all group 2 elements, okay, form the M2 plus ion in a chemical reaction, okay, by losing 2 electrons. The alkaline metal easily oxidize and very good reducing agent. Descending group 2, okay, the atomic size increases and the ionization energy decreases, so easier to form metal ion. Okay, thus the element become more reactive. Okay, from top to bottom group 2. Okay, similar with group 1, alkaline earth metal also react with oxygen, um, but not as rapidly as group 1 elements. So all group 2 elements react with oxygen to form metal oxide. Okay. Okay. All alkaline metal also react with water under suitable conditions to form their respectively oxide or hydroxide. Okay. And produce gas hydrogen. Okay. For beryllium and magnesium react with water to produce metal oxide. Okay, metal oxide. For beryllium produce beryllium oxide, magnesium produce magnesium oxide, and hydrogen gas. But for calcium, strontium, and barium react with water to form metal hydroxides and hydrogen gas.